You know, in boardrooms everywhere, there's this really seductive story making the rounds, that the age of the human software developer is, well, coming to an end. It's a narrative that's being supercharged by the incredible rise of AI. But as we're about to see, it's hiding a pretty dangerous financial illusion. Let's break it down.
So, this is the big question, right? The one on everyone's mind. With generative AI that can now churn out functional code from just a simple English sentence, it's easy to see why so many people think that traditional engineering jobs are about to go extinct. But is it really that simple?
And this whole idea has a name: vibe coding. The promise is honestly revolutionary. It's about democratizing software creation, letting anyone with a great idea build an app without having to write a single line of code. I mean, for businesses looking to innovate faster and slash costs, that sounds like a dream come true.
And this powerful idea, it fuels what we're calling the AI coding dream. I mean, think about it. If you're a business leader, the idea of generating software on demand with a cheap AI agent instead of paying an expensive team of engineers, well, it's almost impossible to resist. It sounds like the ultimate win for efficiency.
But, and this is a huge but, here is the critical flaw in that dream. The entire financial model is built on a totally faulty assumption that just generating code is the same thing as delivering a finished, secure, reliable product. And I'm here to tell you, those are two wildly different things with vastly different costs.
This brings us to what the experts are calling the 70% problem. See, AI is fantastic at spitting out that first 70% of the code for a project. You know, all the boilerplate, the basic user interface. It creates this powerful illusion that you're moving at lightning speed. But that massive chunk of code, it might only represent 10% of the actual difficult, nitty-gritty engineering work needed to ship a real product.
And this is where we get to the core of the issue today, the efficiency paradox. It's a really counterintuitive idea that says the very tools that make individual coding tasks faster can actually grind the entire system's delivery to a halt. So here's the crucial point. When AI makes writing code practically free, what happens? We just get more code, a lot more. It's kind of like this old idea called Jevons paradox. Suddenly, the real bottleneck isn't writing the code anymore. It's making sure all that AI-generated code actually works together, that it's secure and that it's stable. And that's the new, much, much harder problem to solve.
So how does this code volume just explode? Well, for one, AI loves to proliferate boilerplate, just duplicating logic over and over instead of creating smart, reusable components. It also causes what's called semantic fragmentation, where maybe different AI agents solve the same problem in slightly different ways, creating this confusing tangled mess. The end result is classic bloatware. The software gets slow, it gets heavy, and it becomes an absolute nightmare to maintain.
This explosion of code, it isn't just a mess, it's a direct financial risk. When you let AI run wild without expert supervision, you're not just creating messy code. You're creating a hidden and potentially catastrophic liability right on your company's balance sheet.
And you might be thinking, okay, this is all just theory, right? Nope, this is very real. The source material points to a critical case study from 2025, the Lovable security breach. Lovable was a whole platform built on this promise of vibe coding, letting users generate web apps just by describing them. But under the hood, it created a massive, hidden vulnerability.
So what was the fatal flaw? Well, the AI generated an app that worked perfectly. It did what the user asked. But it completely forgot a standard, absolutely critical security feature called row-level security. Because of that one omission, attackers could easily access sensitive user data. And the lesson here is just brutal, but so important. Just because code functions doesn't mean it's secure. An expert engineer would have spotted that in a second.
And there's actually a term for this kind of code, AI slop. It's code that looks fine, it might even work, but it's so poorly built that it's nearly impossible to maintain. This isn't just a minor headache. It's a new kind of technical debt that's already costing companies around the world trillions of dollars every single year.
And if you want to see this risk in dollars and cents, just look at what's called the rule of 100. A bug you catch way back in the design phase has a baseline cost to fix. Let's call it 1x. If you catch it during coding, it's already 10 times more expensive. But if a bug, like the one that caused the Lovable breach, makes it out into the wild, into production, the cost to fix it explodes by 100 times or even more. These unsupervised AI workflows are pushing more and more bugs into that most expensive phase.
Okay, so it sounds pretty bleak, right? But what's the solution? This is where we pivot. The key isn't to get rid of AI. It's to completely reframe the role of our human experts. They're not a cost you need to eliminate. They are the critical component that turns this dangerous liability into an absolute competitive superpower.
Let me give you an analogy. Think of AI as a Formula One engine. It's incredibly powerful, capable of mind-blowing speed. But what happens if you put a total novice behind the wheel? Or worse, no one at all?
It breaks down like this. On one side, you have the AI engine, giving you all that raw speed, that power, that massive code generation. But on the other, you have the expert driver, your senior engineer. They provide the control, the strategy, the understanding of security, constraints, and the big picture. Without that driver, the engine's power isn't just useless, it's incredibly dangerous.
And look, this isn't just a nice idea. We've got the data. The analysis shows that when senior engineers use AI as a tool, as a co-pilot, they can see a productivity multiplier of up to 3 times. They use it to handle the boring stuff, freeing them up to focus on architecture and security. But for junior developers, productivity can actually go negative because they end up spending more time fixing the AI's subtle, hard-to-spot mistakes.
So let's just put it all on the table. When you compare the two models, the difference is just stark. The vibe coding model gets you high speed right out of the gate, but you pay for it with low security, sky-high maintenance costs, and terrible stability. The expert-led AI model, though, it gives you the best of both worlds. You still get that high velocity, but you also get high security, low maintenance costs, and a rock-solid, stable product.
All right, so how do you actually do this? How do you put this into practice? Let's walk through a strategic roadmap to take AI from just being a cool experiment to a reliable tool you can build expectations around. The goal is to get real, sustainable value. It comes down to 4 key steps. First, you have to mandate a human-in-the-loop review for all AI-generated code, no exceptions. Second, you've got to redefine what productivity means. It's not just about speed anymore. It's about stability and low failure rates. Third, a huge mindset shift. Start treating every single line of code as a maintenance liability, not an asset. And finally, adopt a hybrid model. Focus on empowering a smaller number of highly skilled engineers with these powerful tools.
So when you boil it all down, what's the big takeaway? The future isn't about getting rid of developers or having no code. It's about empowering your best people to do their best work faster. The future is expert code accelerated.
And that leaves us with one final question, one for you to take back to your own team. As you bring AI into your workflow, are you truly building a powerful engine for growth? Or, without the right expert driver at the wheel, are you just building a very expensive crash waiting to happen?